US Physics Olympiad, year 2011, F equal MA, first round. Problem number 12. Solution for this problem you can find by reference below this video in the description. You are given a large collection of identical heavy balls and lightweight rods. When two balls are placed at the ends of one rod and interact through their mutual gravitational attraction, as is shown on the left, the compressive force in the rod is F. Next, 3 balls and 3 rods are placed at the vertices and the edges of an equilateral triangle, is shown on the right. What is the compressive force in each rod in the latter case? Solution. As we can see on the left picture, we have force of gravity equalized by compressive force, and force of gravity equal G multiplied by m square over a square, where a is a distance, the size of this rod, and m is mass. Now if we look at the right picture, we have construction in which for each mass it connected through each rod with neighbor balls, and there are only 2 forces of gravity and 2 forces of compression, and we can see that force of gravity between 2 neighbor balls equalized by compressive force, same compressive force F in each case. It means that force of compression will be the same as in first case. So it means that solution is C, force equal F. Problem number 13. Solution for this problem you can find below of this video in the description reference. The apparatus in the diagram consists of a solid cylinder of radius 1 cm attached at the center of 2 discs of radius 2 cm. It is placed on the surface where it can roll but will not slip. A thread is wound around the central cylinder. When the thread is pulled at the angle theta equal 90 degrees to the horizontal, directly up, the apparatus rolls to the right, which below is the largest value of theta for which it will not roll to the right when pulling on the thread. Solution. Let's extend our thread through this base of this floor and check if this extension going to the right from the point O where this construction touched the floor. Because we don't have any slipping, it means that we can take this point as a point of rotation for all construction. And if we look at this picture, we have force of friction which are going through point O. Also we have force of gravity which is going through this point O, and we have normal force which is going through point O. And all these forces, they create zero torque for this construction around point O, and only force of tension create counterclockwise or clockwise torque around this point. It means that everything depends where this extension for this thread cross this floor, to the right from point O or to the left. If it's going to the right, we have total torque is counterclockwise, and our construction will roll to the left. If it's going to the left, it will create torque clockwise, and it will go to the right. So solution is 60 degrees. That's a critical angle for which this extension going exactly through point O. Problem 14. Solution for this problem you can find below this video on the reference in the description. You have 5 different strings with the weights tied at various points, all hanging from the ceiling and reaching down to the floor. The string is released at the top, allowing the weights to fall. Which one will create a regular uniform beating sound as the weights hit the floor? Solution. We know that height equal 1/2 gt square when the body is on a free fall. So it means that for equal period of times we have next heights h, 4h, 9h and 16h for the same period of time. So if we look at these strings, only string D create this sequence. So that's the solution, D.